Good morning, everyone. Welcome to Curiosity Students Question the World and Connecting Taiwan. Our topic for today is Mars, Conquest and Colonization. I'm your host, Iris, from National Yangming Jiao Tong University. It's our honor to have Mr. Lehman with us today. And before we start, I'd like to provide a brief overview of our program, Curiosity Student Question the World, and introduce our team. In the following section, to benefit our audience, I will switch to Mandarin and explain the process of the Q&A activities. 我们的讲座是由好奇学生大哉问、大同大学、国立台北教育大学、辅英科技大学、铭传大学、东吴大学、静宜大学、辅仁大学、台北科技大学、慈济大学、嘉义大学、东海大学、台北市立大学、中原大学联合主办。谢谢现在线上参与的各所国内外学校学生，也感谢业界人士各位伙伴的热烈响应。好奇学生大哉问的主旨是建立一个学习交流的平台，邀请海内外专业人士每月进行一次的专题讲座，分享他们的知识与经验，借此激发同学们的好奇心与自主学习的动力，并鼓励大家大胆提问，成就非凡未来。活动将安排在每月第3周的礼拜五上午10点10分到11点45分，以线上视讯方式进行。参与方式非常简单，大家只需提前在 KKTix 报名并提出问题，演讲者就将根据这些提问来调整讲座的内容。活动中也可以透过填写问题表单参与 Q&A， 也可以透过按荧幕右下角的回应功能鼓掌致谢。活动后也欢迎大家加入我们的工作团队，共同学习团队合作能力。接着我们先来邀请我们的节目主办人刘登凯博士为各位同学介绍提问奖金的部分。我们有请刘博士。
好，谢谢主持人。First of all, I would really appreciate David accepting my invitation to join our program, and so grateful that you can spare time and share your knowledge about Mars. And I'm going to switch to the Mandarin the following, talk about our program. 也同时感谢这个张桂祥张博士来替我们介绍，可以跟我们的嘉宾这个对话呀。那我们这个讲义分成2个部分，第一个部分是这个事前的，刚刚主持人讲过，事前的话是希望同学能够提问，那这样的话对于我们的讲者来讲，他有个影响力，他就知道说他同学想听什么，他不见得答案对你们的每一个问题他都会答出来，但是他是基本上会把所有的这个融合起来。所以我在那个事前之前，我会挑3名出来，第1名我给1000块钱台币的奖金，第2名是500，第3名是300。那同时呢，在这个讲完以后呢，那欢迎同学随时是可以提问。那我们这个背后有这个 QR code。那同样的，我在那边提问的同学里面，我举出来3名，第1名也是1000，第2名是这个500，第3名是300。OK， 所以希望大家呢踊跃提问，这个机会不大。我这个朋友他是非常非常有经验的啊，那欢迎同学问问题，好不好 ？OK， 好，我就把这个现场的交回我们的主持人。
谢谢刘博士的说明。接着在这边跟同学讲解一下我们的节目流程。在11点结束演讲后，会有15分钟的专家对谈，接着就会进行 Q&A 活动环节。如果听了演讲者精彩的演讲以及专家对谈后，有任何疑问，都欢迎同学透过聊天室连结发送问题。我们将现场选出3个好问题，并给予提问奖金，也会选出演讲前报名表单中的3个问题，共6个得奖名额。问题可以包含针对演讲者的专业领域以及心路历程来询问，也请得奖同学在活动结束后留下来加入得奖的 LINE 群，确认加入 LINE 群后再离开。逾时或是没有上线听演讲的同学，奖项会被取消哦。麻烦各位同学配合以利后续奖金的颁发作业。提问的部分还是可以用中文提问，但提醒各位，本次的演讲会以英文形式呈现。大家可以点选荧幕右上角的最右边的3个点，开启字幕翻译。 本次演讲主题是由 Mr. Lehman 主讲的火星征服与开拓。接着，我们非常荣幸邀请到在台湾太空产业领域有卓越贡献的张贵祥博士，为我们介绍今天的讲者 Mr. Lehman。简单为各位介绍张博士。博士曾任国家太空中心主任，推动了台湾的太空计划，从福卫1号到福卫7号都有张博士的身影，为台湾的气象预报还有灾害的检测都带来了非常重要的帮助。那让我们接着欢迎张贵祥博士为我们介绍讲者。
Good evening, David.
Hello, Dr. Chang.
Hi, nice to see you again in the internet. Okay.
Yes.
I would like to introduce yourselves to the audience. So now I will switch to Mandarin. Okay.
Okay.
我想各位同学，各位老师，大家好。那我是张贵祥哈。那David 跟刘博士，我们在去年10月的时候有在台湾见一次面，然后尤其是刘博士哈，我认识他非常多年哈，他对这个科普教育或者是台湾的这种热爱啊。让我们觉得非常非常的钦佩啊！今天也很高兴能够在这边来介绍Mr. David Lehman 哈。那今天我们很荣幸的邀请到Lehman 哈，他在美国的 NASA 的 JPL 工作了40年哈，这是很不简单的一个经历哈。那他担任非常多的计划专案经理哈。那大家知道 JPL 主要是探索外太空的科学啊，这些技术啊的这些主要的一个任务哈。那他参与的计划包括 Odyssey 哈，包括 Deep Space One， 包括这个 Gravity Recovery and Interior Laboratory 的探月计划等等哈。各位可以看到，这些都是超越地球引力以外的这些计划哈。那 Lehman 在加入 JPL 之前呢，曾是美国海军的核工工程军官，然后他以海军上校身份退役，然后参与的 NASA 任务哈，然后屡获很多殊荣哈，包括杰出成就奖与卓越领导奖。他在退休后呢，担任 NASA 太阳系大使哈。致力于向大众推广太空探索的知识跟魅力哈。那今天呢，Mr. Lehman 先生将带领我们回顾人类探索卫星的历程，并展望未来如何实现火星任务与殖民计划哈。让我们以热烈掌声欢迎 Mr. Lehman。Okay, David, please go ahead.
Okay, thank you, Dr. Chang. It's great being here, and thank you, Dr. Liu, for inviting me. I'm looking forward to this night. To me, it's a night. For you, it's the morning for a long time. And so the title of my talk today is Mars Conquest and Colonization. And I worked for NASA's Jet Propulsion Lab for 40 years, and about half that time, I worked on the Mars program. And so I put together these set of charts to talk about what has gone from the past to the present and my ideas of what will happen in the future. So I'm going to go ahead and share my charts. Hopefully you'll be able to see these. Here we go. Yes, and I'm going to go full screen. And so Mars has been investigated a long time by us, and when we look at it in the sky, it looks like a red dot. It looks like a red dot among the stars, and the reason it looks like that is it's lots of rusty iron on it, and the United States and other countries have been sending spacecraft there for a long time. But landing on Mars is extremely difficult. About 40% of the missions that tried to land on Mars failed because it's very, very tough. It's very, very tough to land on Mars. So I'm going to show you a video about what it's like to land on Mars. And this happened a little over 4 years ago. It's about the Perseverance rover. This is a NASA mission. And its target site was a place called Jezero Crater. Jezero Crater. And the high-level purpose of the mission is to seek signs of past life, So I'm going to show you this video now.
We have deemed Perseverance ready to execute entry, descent, landing on our own.
Information is our entry interface. Perseverance is currently going 5.3 kilometers per second, about 120 kilometers from the surface of Mars. It will start controlling its path to the landing target. And it has deployed, and we are seeing significant decelerations. The heat shield has been separated. Perseverance now has radar lock on the ground. The back shield has separated. 5 meters of target, about 20 meters off the target.
Lego Delta, nominal.
Touchdown confirmed. Perseverance.
So the Perseverance rover, it's been on Mars since February 2021, and it's still working. It's still working, and I'll go into more details about this particular rover. But here I put in the topics I'll talk about today: facts about Mars, the beginnings of the space age, the early days of Mars conquest, the conquest and colonization of Mars, and possibly maybe even the future of Mars colonization. So here's some of the facts about Mars. It's the fourth planet from the sun. And like I said, it looks like a red dot among the stars when you look at it. And it's smaller than Earth. It's about 1/2 the diameter of Earth. And Mars, like the Earth, it has 4 seasons. Right now on Mars, it's springtime, just like it is here on Earth, the northern hemisphere. And unfortunately, in order to live on Mars, the atmosphere is not very agreeable. So the atmosphere, the atmospheric pressure is about 1% of what we have here on Earth. And it's largely carbon dioxide, whereas we need oxygen in order to breathe. So when you go to Mars, you've got to remember to bring your spacesuit with you. And Mars is colder than the Earth. In the wintertime at the poles, it can get down to minus 153 degrees centigrade, whereas at the equator in the summertime, it gets up to a balmy 20 degrees centigrade. And Mars has the biggest mountain in our solar system. It's about 2.5 times taller than Mount Everest, and it's as big as France. Mars has 2 little moons called Phobos and Deimos. And there's water on Mars. That is, there's water ice on Mars. And if you melted all that ice on Mars, it would cover it to a level of about 35 meters. So there is a lot of water on Mars. And landing on Mars is extremely difficult. Like I said earlier, only 40% to date have been successful, and no astronauts have been to Mars yet. And one of NASA's goals is to try to do that probably in the next 30 years. We'll see if that's possible or not. But that's the high-level goal. And here to talk about how this goal is going to come about, on the left, I'm showing a photograph. This is Dr. Robert Goddard, and it was taken in 1926 in the United States in the state of Massachusetts. And Dr. Goddard, he's known as the father of the modern rocket propulsion. And he invented the first rocket motor to use liquid propulsion using alcohol and oxygen. And so he wrote a number of papers about his invention, and that spread throughout the world, including to a place where I live on the right. This is in Pasadena, California. And this photograph was taken in October 31st, 1936, in Pasadena, where I live. This is in the western part of Pasadena. And these fellows here, they're doing their first rocket test in the northwest part of Pasadena. And they were from the California Institute of Technology. The three on the left were from the California Institute of Technology. They were graduate students. And the third from the left, his name is Frank Malina. He eventually became the second director of JPL. So they were attempting to test their rocket that day. And unfortunately, the first three times they tried it, the fuse blew out, so nothing happened. But on the fourth try, the rocket motor actually worked. But unfortunately, the oxygen feed line caught fire and everything blew up on them. So they got no data that day. But they continued to work in their rocket research. And eventually they started having some successes. And so this picture here, this is what I would call the start or the beginning of the Jet Propulsion Laboratory, JPL, of the California Institute of Technology on October 31st, 1936. So they continued their work on rocket propulsion. And in 1947, this is when JPL hit the big time. And they had a contract from the U.S. Army to develop rockets. And this is their first successful launch of what's called the Corporal E rocket. And the Army liked this rocket a lot. And so they bought a whole lot of them from the Jet Propulsion Lab. And eventually, this particular rocket was used in the early days of the Cold War, and it was stationed throughout Europe during the early part of the Cold War. But if you notice on the heading for this chart, it says it's round 21. So it took them 20 rounds of all kinds of different problems with this rocket, but it wasn't until round number 21 until they eventually got this rocket to work. So I imagine they must have been very, very frustrated, these folks from the Jet Propulsion Lab. So JPL continued to do work in developing rockets, and then they had the idea to spread out to building spacecraft. And that came about here, shown here. This is on the left, this is the model of Sputnik 1. This is built by the Soviet Union, and this was launched in October of 1957. And this caused a big commotion in the whole world because they were the first to launch the spacecraft. And the people in the United States thought, wow, we're better and smarter than those people. How could they do that before us? But this particular spacecraft, Sputnik 1, it was about 0.5 meter in diameter and had a mass of around 84 kilograms. So it was, compared to what the US did, it was much bigger. And so in response to that, the United States tried to get its act together. And the picture on the right, this is a picture of the US's first spacecraft to go on orbit around Earth, and that was called Explorer 1. And Explorer 1 was built by the Jet Propulsion Laboratory of the California Institute of Technology. And this particular spacecraft, it had a mass of only about 14 kilograms, and the diameter was only about 15 centimeters. You can tell the diameter by the width of the hands of these people trying to hold it up. And on the left, this is Dr. William Pickering. He was the director of JPL at the time. And in the middle is Dr. James Van Allen. He was from the University of Iowa, and his team built the scientific payload that went into Explorer 1. And then on the right, this is Dr. Wiener von Braun from the Army's, he was from Alabama, and his team built the rocket that actually put it into orbit. And so Explorer 1 was built by the Jet Propulsion Laboratory, and that happened in January 1958. And then a few months after that, NASA was created. And then a few months after that, NASA decided to make JPL one of its NASA centers. And so that's continued ever since. And so JPL since that time has built spacecraft or instruments that's flown to every planet in our solar system. And we now even have 2 spacecraft operating in interstellar space. So that was Explorer 1. And this is when JPL shifted gears from building rockets into building spacecraft. And this particular chart, this gives sort of a feeling of people having ideas for actually going to Mars. And Dr. Braun, while working in New Mexico, what he did was he put together a concept for human exploration. He put a concept for human exploration, and that was published in a book, and then it was serialized in a magazine. And this is about, can we get to Mars? Is there life on Mars? And so this work, it was an early influential, but very naive view of the first humans going to Mars. But even back then, Dr. Braun felt that you probably couldn't expect that to happen within the next 100 years or so. Within the next 100 years or so. And here is about the Mars science in the 1930s. And the U.S. witnessed a series of, in the 1960s, the U.S. had a series of missions that dispelled the idea of living Mars. And the early mariners from JPL that were built for NASA found that it would be cold, frozen, cratered, and largely was forgotten was the idea of sending humans to land on Mars. And it was far beyond the state of the art. And they were downscoped into the Viking missions in the early 1930s. And this is a picture of Dr. Pickering, the director of JPL at the time. This is with the model of Mariner 4. And Mariner 4 was the first spacecraft to fly by Mars. First spacecraft to fly by Mars. And that's when we got our first detailed close-up pictures of what Mars looked like. And Mariner 4, this particular vehicle, it weighed about 250 kilograms, and it was about 1 meter in diagonal and about 50 centimeters or half a meter in width, or height rather. And this is a picture of Mariner 9 that was built by JPL, and that went into orbit around Mars in 1971. And this was the first spacecraft to orbit another planet, the first spacecraft to orbit Mars. And this vehicle, it had a mass of around 1,000 kilograms and a volume of about a cubic meter. And then for the Viking missions landed on Mars in 1977, and these were the first landers to land on Mars. And this is where Viking performed the first search for organics and the life presence on Mars, and it was headed up by the Ames Research Center, which is in Northern California. However, the experiments were generally viewed as unsuccessful at detecting life, but we did learn a lot about preparing the way for future landers on Mars. And a little bit about my background. I was 40 years at JPL, And one of my major projects I work on, I was project manager for the Mars Pathfinder. I was a technical manager for the Mars Pathfinder avionics subsystem. And what our big claim to fame was, we landed the first planetary rover on Mars, and that was in July of 1977. And here's a picture. Here's a picture of this rover right there. It was called the Sojourner rover. This was the first planetary geologist. And the Sojourner vehicle, it was about as big as a bread box, and it was about it had a mass of around 11 kilograms. It was solar powered, 6 wheels, and it used a radio transceiver to communicate with the main lander. So that was the first planetary rover. And a little bit about JPL. There's a picture of the United States. This shows all the different NASA centers. And JPL is in Pasadena in sunny California. And so on the right, this is a picture of JPL. And above it is the San Gabriel Mountains. And what's nice about our area is that in the wintertime, you can go skiing up in the mountains, and then in the morning, and then later that day, you go to the beaches of Los Angeles to go surfing. And on the picture on the right, the lower right, this is where the first rocket tests were done in Pasadena at what would become the Jet Propulsion Laboratory. And here I show on the left, this is the director of JPL. Her name is Dr. Laura Leshan. She's a very impressive lady. She has what I call command presence. When she walks into the room, everybody wants to know what she has to say. And Dr. Leshan, she has a PhD from Caltech. And prior to coming to JPL, she was the president of Worcester Polytechnic Institute. And prior to that, she was the dean of the School of Science at Rensselaer Polytechnic Institute. And then on the right, this is Marvina the Martian. And because JPL is the headquarters for the Mars Exploration Program Office. So we have occasional visitors from Mars. And so I'm showing Marvina there. And one day I was talking to Marvina. She says, "David, how much do you weigh?" I said, "Well, I weigh 81 kilograms here on Earth." And Marvina said to me, "Well, do you realize if you lived on Mars, you'd only weigh 31 kilograms? I go, "Wow, that's good news. That means I'm not fat. I just live on the wrong planet. So what's going on at Mars? Right now, Mars is a very busy place. NASA is operating 3 orbiters that are orbiting Mars. And NASA has 2 rovers at Mars that are roving around Mars. The European Space Agency, it has 2 orbiters at Mars. India has an orbiter at Mars. United Arab Emirates, or UAE, has an orbiter at Mars. And China has an orbiter at Mars. So it's right now, it is a very, very busy place. And in this graphic, I show what sort of the goals NASA has exhibited or has been working on for the Mars exploration. First, right around 2000 was follow the water, and then we shifted gears to explore habitability, and now we're seeking signs of life. Meanwhile, while doing all this, preparing the way for future human explorers. And coming up soon, I show on here a mission by the Japan called JAXA. There's also a Chinese mission in the works over here, and then also there's a ESA with a lander in Mars, and then also China is interested in sending more missions to Mars. So Mars is becoming a very busy place. A little more in my background. Just before I retired from JPL, I was the project manager for 8 years for Mars Odyssey, and Mars Odyssey was launched in 2001, and it's still operational, still working. And our big claim to fame was the first detection of frozen water beneath the surface of Mars. And so this vehicle is used to collect science data about with the infrared camera, and it's also used as a relay for relaying data from the Mars landers, from the Mars rovers. And this is the Mars Curiosity rover. It landed at Mars in 2012. And this vehicle, it's as big as a small car. It has a mass of around 900 kilograms, and it's 3 meters wide, 3 meters long, and about 2 meters high. It's a six-wheeled vehicle, and the purpose of this mission of this rover is to study the geology of Mars, the climate at Mars, the atmosphere at Mars, the radiation environment at Mars, seek science of past or present life, and pave the way for future human explorers. And so this one has been a real workhorse, this particular rover, and it's been roving around a long time. And so if you look at the left middle wheel on this machine, you'll notice that there's a lot of damage to this wheel. And this is the left middle wheel. So this is after 10 years of operation. 10 years of operation. This is an aluminum wheel with titanium treads on it. But the engineers found out that when they saw this, the engineers thought, what are we going to do? This is a big problem. And the engineers since found out that if you just drive backwards, this thing will work a long time. So that's why the Curiosity rover drives backwards. And this is an image of that Curiosity took. And this is, if you look at this flowery-like artifact and these two other spherical artifacts, you wonder how this happened. Well, right now, Mars is a dry, barren desert, but billions of years ago, water flowed on Mars. And what the scientists thought is that minerals carried by this water cemented together to form this flowery-like object. So we don't know if life exists on Mars or ever existed on Mars, but we do know that on Earth, where there's water, there's life. And one day, Curiosity took a video of the sun, and lo and behold, they discovered, what is this object going through here? Well, it turns out this is not Marvina the Martian, and that turns out to be the Martian moon Phobos. The Martian moon Phobos, which has a diameter of about 16 kilometers. And this is the Perseverance rover. This is a selfie. This is the one you saw in the first video. And this vehicle has a lot of heritage to the Curiosity rover. It's as big as a small car. It's a little heavier. It's around a little over 1,000 kilograms, and it's 3 meters wide, 3 meters long, and 2 meters high. And you can see the wheels are definitely different on this vehicle. And the purpose of this mission is to study the geology of Mars, the climate at Mars, the atmosphere at Mars, seek signs of past or present life, and pave the way for future human explorers. And when this vehicle landed on Mars, it carried with it 43 Mars sample tubes. And so what this machine is doing, it's drilling into these, like this rock nicknamed Rochette, to get Mars samples, and it's putting them in these Mars sample tubes. And then the idea is a future mission will come and get those Mars sample tubes, return them to Earth, so we can find out what's really going on at Mars. Did life ever exist on Mars? Does life exist on Mars now? And there's a picture of me, there's Dan Kai on the left at the JPL Mars yard, and on the right, that's a working prototype of the Perseverance rover, and that's used to train rover drivers and also to do experiments going up different inclines and around different obstacles. And this machine here was carried to Mars by the Perseverance rover, and this is the first helicopter to ever fly in another world. And this vehicle had a wingspan of about 1 meter and had a mass of about 1.2 kilograms. And so this was a solar-powered vehicle. This was the first aircraft to ever fly in another world. And flying on Mars is not easy because the atmospheric pressure is so much less. So this was a big technology development, a big technical challenge to do that. And the lady in charge of that development is shown here. Her name is Mimi Ong. I heard her give a lecture shown in the title here. So Mimi is a very impressive lady. She has a bachelor's and master's degree in engineering from University of Illinois. And she's a great leader, a great engineer, and a great communicator. So she's a very impressive lady who did that. And I'll talk more about her later. So here's a question about this Mars helicopter, and NASA's decided they're going to build another one, but why did NASA recruit college students from Taiwan to design this next Mars helicopter? Why would they come to Taiwan to design this next Mars helicopter? And I found this on the internet. The reason is because they heard they all work for free. So that's one of the reasons why NASA is thinking about coming to Taiwan to have their students design the next Mars helicopter. And here I'm going to show you what NASA discovered this past summer. And this lady, Dr. Cable, will explain what's going on here.
What does this rock have to do with our search for ancient life on Mars? Everything. I'm Morgan Cable, a scientist on NASA's Perseverance rover team. Let's take a closer look. 3 things about this rock jump out at us. These whitish veins of calcium sulfate are clear evidence that water once ran through the rock. In this reddish middle area, the rover's Sherlock instrument detected organic compounds. And these tiny features that look like leopard spots, Pixel found they indicate chemical reactions, which could have been an energy source for microbial life. We've never seen these 3 things together on Mars before. We have lots of questions about how this rock formed and whether it hosted microbial life billions of years ago. But to fully understand what's going on here, we need to get these rocks back to labs here on Earth. In the meantime, as the science community investigates this data, we've added a sample of this really compelling rock to Perseverance's collection. It's awaiting retrieval by a future mission, and we can't wait to study it up close.
So in this video, what they found is something we've never seen before other than on Earth, is this whitish material is calcium sulfite, which indicates the water flowed through here billions of years ago. And then this reddish material is organic compounds. And then these little leopard spots indicate there was an energy source. And so we've never seen these 3 things before. So maybe life did exist on Mars. And so this particular sample has been put in. This is Mars sample tube number 22. It has this particular sample. And in the future mission, we hope to bring this sample tube back. And so here's some test engineers at JPL at the Mars yard and doing a test of dropping these Mars sample tubes from the belly of the working prototype of the Perseverance rover. And you see how it drops flat like that. So they did this test many times, and they want to make sure it always drops flat. See how it drops flat like that? So they did this many times. That's what we do at JPL is test, test, test. But one day they did this test, and look what happened. It stood straight up. And the next mission doesn't know how to pick up a tube that's straight up. So look at the expression on that lady's face. So we've started to drop these tubes on the ground at Mars. And this is the first tube in a place called Three Forks. So you'll notice it dropped flat. That's good. And then all 10 tubes, as planned, have been dropped on the ground at Mars, waiting for retrieval. And all of them dropped flat. So now NASA is thinking about how do we get these tubes back. And I'll show you a video about one potential plan to do that. There's Mars. This is the Perseverance rover preparing its tubes to be returned to Earth. The Percy will observe the landing of a sample retriever lander, or SRL. Percy will travel over to the lander, and the tubes will be transferred from Percy to the forward end of a Mars ascent vehicle. This vehicle can hold approximately 30 Mars sample tubes. Percy will back off. This hatch will open. This is the Mars ascent vehicle, the 2-stage rocket. First stage will blast off. It's about a 10 or 20 second burn. Then the second stage will light off, another 10 or 20 second burn. This is to put the 30 Mars sample tubes in the Mars orbit. Another vehicle called the Earth Return Orbiter will rendezvous and capture the tubes. Tubes to be transferred to a receiving system. The Earth return orbiter will leave Mars orbit to return home. When it gets close to Earth, it will release 30 Mars sample tubes and it'll land in Utah in the United States of America. So that's one concept for the Mars sample return program that NASA and the European Space Agency are working towards. So here I'm going to show you the evolution, in my mind, of a Martian. I found this I was in Poland last year, and I found this graphic. It came from NASA, but I found it in Poland. And these are the different rovers that NASA has sent to Mars. There's the Sojourner rover, and then there's the Spirit and Opportunity rovers. Those rovers are around 200 kilograms. And then you have the Curiosity rover, 1,000 kilograms. The Perseverance rover, a little over 1,000 kilograms. And maybe the next rover after that will actually be astronauts going to Mars. So maybe that's a possibility. And NASA has some ideas on how to do that, and that's called the Artemis program. And in the Artemis program, what NASA plans to do is collaborate with international and commercial partners to set up the first long-term presence on the moon. And the international partners include European Space Agency, Japanese Space Agency, Canadian Space Agency, and then commercial partners, which include companies like SpaceX and Blue Origins. And the idea is to have a long-term presence on the moon. When we went to Apollo, we only were there from 1969 to 1972, so it was only 3 years. So now we want to do a long-term presence. Another goal of Artemis is to land the first person of color on the moon, and then use what we learned on and around the moon to take the next giant leap of sending astronauts to Mars. So here we go. Why did the astronaut from Taiwan buy himself a ladder that was 225 million kilometers long? Here I'm showing you a graphic. There's the Earth, there's Mars, there's this giant ladder with an astronaut from Taiwan. Why would he do that? Why would he buy a ladder like that? And my guess is that he would climb up to Mars, put a giant sign in the sky that says, "Honk if you love Taiwan. Honk if you love Taiwan." So that completes my lecture, and I think that possibly in 30 years, NASA and other partners will be sending astronauts to Mars, and maybe this is a picture of that astronaut at Mars, maybe in about 30 years. So that concludes my briefing, and I will stop sharing my screen and open up for any questions.
Yes, thank you so much for your wonderful speech. And we'll move on to the fireside talk. And so I will switch to Mandarin to explain it. 那我们感谢 Mr. Lehman 的精彩分享，我们将进入专家对谈的时间。专家对谈的时间会直到11:15。那在专家对谈之后呢，会进行 Q&A 环节。若大家在现场有任何疑问，都欢迎利用这段时间提问题，也欢迎大家将 Mr. Lehman 还有张贵祥博士的画面定选至画面前方，以获取更佳的观看体验。让我们再一次邀请张贵祥博士针对 Mr. Lehman 在讲座内容中的主题做深入讨论。
Hello, David.
Yes, Dr. Chang.
Yeah, my job is that we should have some I think the conversation regarding your lectures. You just presented earlier. I think first of all, thank you for your presentation. I think that's got a lot of the information and knowledge to the audience, especially for the students. I think I have been working for space program for over 30 years. I always have been asked a question because we work for government space program. So why we spend a lot of money, actually the budgets, to explore the space? Can you explain a little bit why the JPL or NASA they would like to spend a lot of budget to the explore the outer space, including the moon and the Mars, from your personal point of view?
That's a good question. That's a good question. And I think that, to me, it's part of our human characteristics to want to explore, to want to see what's on the other side of the atmosphere. And I think it's just embedded into our DNA that we want to explore things like that. And for example, if I'm going to the moon, why would we want to ever go to the moon? And I think it's all part of this understanding the science involved with going to the moon, the science involved. It's also sort of a national prestige. When the United States went to the moon with Apollo, we were in a competition with the Soviet Union. So it was all part of national prestige to show that we could be better than them, even though it may not have been a worthwhile goal. That's what we did. And now we're looking at the science going to the moon. Another thing I could see what happen eventually is people like billionaires like to become astronauts. Have you ever noticed that? All these billionaires want to try to become astronauts, right? So I think what eventually will happen is these billionaires will want to go to the moon, And a good example of why you want to do that is last Thursday in North America, we had a total lunar eclipse of the moon. And when you look at the moon from the Earth during this total eclipse, it looked reddish. And it was just amazing. But I can just imagine tourists would want to go to the moon to observe this eclipse from the moon standpoint. It would really be something. It would really be a beautiful setting. So that's an example of tourists wanting to go to explore space, to become astronauts, go to the moon. And then maybe the next step after that is actually doing mining on the moon. On the moon, there's reported to be high quantities of helium-3, which could be used as a fusion source for a fusion reactor. And just a small amount of this helium-3, if you could bring it back to Earth, could supply a lot of our energy needs for humans. So there's just some examples of why I think there's interest in going to the moon.
Yeah, thank you. A personal point of view is why we go to the space, to moon or to the Mars. I think the curiosity is very important, because curiosity will driven all the technology innovations, including the science as well. But this is why we explain to the audience why we go to the space. Not only why don't you spend the money to the social benefits, to the quality people. Why we go to space? Because our country need to have some technology innovation, and we explore the moon or Mars, maybe not the final purpose. We use this kind of the projects to inspire our students or our scientists to make the innovation on science and technology to the humankind. Okay, so this is my personal perspective on why states need the national space program. Okay, although they spend a lot of money on it. By the way, right now is very hard topics is the Elon Musk. They would like to colonize the Mars. However, I think this is not easy to do it, because the Mars has a very harsh environment, and also the rockets, a very huge rocket, transport to the Mars. I think this is a dream. I think sooner or later that will become true. Maybe 20 or 30 years later. However, if human can, I say, colonize the Mars, okay, now become a legal problem, okay, as we have some like outer space treaty in the UN in early 1970, I believe, okay. So who are going to colonize the Mars, and who would own the Mars, or we call sovereignty issues? This is a legal issue. How do you think about that in the future? Who there will be a lot of computation between the not only the all the strong states on Earth, but also in the Moon and the Mars as well. Okay, so how to overcome this kind of issue? Because maybe we have to fight, okay, on the Mars as well in the future.
Yeah, that's an interesting point. I'm not a lawyer, and I don't know how to explain it, but there is a UN treaty with that, and right now, I don't think there's ever been a case involved with arguing over what's on the moon. We haven't done that yet, but I could see that happening eventually if we ever start doing mining on the moon. Maybe in 20, 30 years that this would become an issue. But going back to what you said about Elon Musk and his new rockets, this Starship rocket, I think they've made about eight tests so far. This is the biggest rocket on the planet right now, and it still has a long ways to go, but eventually NASA is dependent upon that for its Artemis program to send humans to the moon. They're actually, SpaceX not only is going to be providing the Starship rockets, but they also have the contract for the Artemis 3 and 4 landers on the moon. And then Blue Origins, they have the contract for the Artemis 5 lander on the moon. So they're heavily involved with this development from a commercial standpoint. So they're big partners with NASA right now in enabling this Artemis program for us. And eventually, I could see us doing this, going to Mars. But that's an even tougher job than going to the moon.
Okay. I'm very interesting to know whether the Artemis mission will be influenced by SpaceX, because right now the Iran is a close friend of Trump. Okay, so have you heard any news about the Artemis mission? Probably will be changing the later on incorporate with the SpaceX or merge two projects together.
I think that right now the Artemis 2 mission is scheduled to launch in April of 2026, and that's as far as I know. I checked the website within the last month or so. That's still on plan, but that's using the Space Launch System as the launch vehicle. But I could see that all being changed when people start, because it is a very expensive rocket. I could see that being changed to some other rockets. So say, for example, a Falcon 9 or possibly even a Starship rocket. But right now, it's still, as far as I know, on track for April of next year. And that's with 4 astronauts. They've been selected. There's not a land. They're not going to land on the moon. There actually can be a flyby mission of the moon. But I could see a big changes happening with NASA with we have a new administration in terms of the Artemis program.
Okay. In your presentation, you have mentioned about the NASA would like to recruit, or JPL would like to recruit Taiwan students to work for a helicopter. Is that the truth?
Well, no, that's a joke.
Oh, okay.
That's a joke.
Okay.
If they work for free, NASA likes it, I think. So
I don't think they would work for free. Okay.
Oh, they don't work for free? Because I thought all they needed was pizza and Coca-Cola,
Okay.
and that's it, right?
I think the most of students are very, have dream for the space. Okay, I think that's very important because, as I mentioned, the curiosity is very important to at the Einstein say the knowledge is limited. However, the curiosity would encircling the world. Okay, I always believe space program have this kind of spirit, and we can inspire innovation for the student. And this kind of innovation and technology or science would be, I think, would be feedback to the economics of the each state. Okay, that's why we fully support the space program in the every country. Okay. So finally, I would like to thank the Mr. Lehman. We are all friends. Thank you again.
Okay.
I hope that we can turn a lot of the question to the audience. I think that's the most important part. Okay.
Okay.
So
All right.
Yes.
Thank you, David, again.
Thank you.
Thank you.
Thank you, Dr. Zhang and Mr. Lehman. And then we'll move on to Q&A section. 接着我们将进入 Q&A 环节，进入到11:40。如果现场同学有任何疑问，都欢迎利用工作人员背板上的 QR code 或是聊天室中的 Q&A 表单连结问问题。若您的问题被挑中，或是现场参与的观众，也都请提前准备开启镜头以及麦克风，准备与讲者互动。提问问题可追问一题。那若您没有问题，也请说 Thank you, Mr. Lehman。那这是实体现场提问的同学，若您的提问被挑中，也请到台上做准备，站在镜头前与讲者做互动。互动当下可追问一题，若没有任何问题，也请说 Thank you, Mr. Lehman， 并回到座位。那么接着就请我们播放第一个问题。问题是来自大同大学资讯工程学系的同学。他的问题是 Can the extraction of resources on Mars, such as water, oxygen, and fuel, be entirely dependent on in situ resource utilization technologies? At this stage, which technologies will still need to be further refined to achieve sustainability? Yes, welcome, Mr. Lehman.
This is a good question. Yes. All I can say is that when Perseverance landed on Mars, it carried with it an experiment called MOXIE. And what MOXIE did is it converted carbon dioxide into oxygen. It converted carbon dioxide into oxygen. It could produce maybe, I can't remember the numbers exactly. You'd have to go on the internet, but it was around 50 grams per hour or so, and it had about 300 or 400 watts of energy, of power, supplying that. And so that's just the very early beginnings of a way to make oxygen. There's also water on Mars, water ice. So you have to melt that, and then you can use that to convert into hydrogen and oxygen for your fuel system. But to do that, you would need a very large power system, which we do not have right now. So if humans were actually going to live on Mars, you would need a very large power plant in order to make your own oxygen, melt your ice to make water, and in order to develop a fuel system. So this is all possible. But we're in the very, very baby stages of doing that, just the very baby stages of doing that with the MOXIE experiment on the Perseverance rover.
Okay, let's welcome 钟伟伦。同学在吗？
在。Thank you, Dr. Lehman. No question.
Captain Lehman. I'm Captain Lehman, not Dr. Lehman.
Captain Lehman. Thank you.
好，那我们谢谢这位同学。那我们进到下一个问题。 问题是来自圣约翰科技大学电机工程系的黄瑞红，那也请这位同学先做准备。他的问题是 ：What was the greatest challenge encountered during launching Curiosity rover?
As I recall, there was problems with these mechanisms. There was lots of different mechanisms that controlling the machine in terms of the mobility. And it became too much for the team. And so the launch had to be delayed 2 years. The launch had to be delayed 2 years because of all these challenges with building all these mechanisms. So the launch was originally supposed to be in 2010, but it was delayed to 2012 because of these mechanisms used for the mobility system. They just weren't ready on time. So that to me is what the biggest challenge was.
好，那我们欢迎黄瑞红同学，请问有在现场吗？如果有在现场的话，请开麦克风与镜头与讲者互动。
Thank you, Dr. Lehman.
Thank you. And let's move on to the next question. 是来自东吴大学黄有熙同学，那也请先做准备。他的问题是 ：How will the current revolution in AI technology affect the progress of Mars engineering?
Well, these are really good questions, really tough questions. Yes, I just started learning about artificial intelligence about 2 years ago when ChatGPT came out, and it's just amazing because if you looked at my charts, all the funny little graphics, that's what I use ChatGPT to make graphics for me. And so I can imagine somebody who's really into the engineering of this can really do trade studies very quickly. So I just think it's such a powerful tool that I can't even begin to understand how it's going to revolutionize our progress on getting to Mars. But it's just unbelievable of what you can do with this machine. And I know maybe 1/1,000,000% of what it is, and it's just unbelievable what it can do. So I don't know the answer, but I know it's going to be remarkable.
好，那请同学。
I don't have further questions. Thank you, Dr. Lehman.
It's Captain Lehman.
Captain Lehman.
Not Dr. Lehman. I'm a retired Navy
I would
captain.
like to follow up this question. I think sooner or later, AI will be applied in the space technology as well. To my knowledge, currently we have lots of issues or constraint. Actually, it's a constraint on the spacecraft. The one is the power issue. The other is computational issue. Okay. Therefore, we know we need a lot of the computation powers on the AI. Okay. However, the spacecraft's most challenging to the spacecraft is the energy and also the computational knowledge, capacity. So I think it's just the initial phase, but however, I believe sooner or later that would come true for AI technology application on the satellite as well.
OK， 那谢谢张博士。同学有其他疑问吗？
没有了，谢谢。
谢谢。好，那我们来看下一个问题，是来自辅仁大学英文系的郭永峰同学。他的问题是 ：Now that technology can land rovers and explore the surface of Mars, what is NASA's ultimate goal?
What is NASA's ultimate goal? I say right now, I showed that in my charts, and that's this Mars sample return. There was every 10 years, NASA commissions a study of what is the most important thing for exploration in space. And the Mars sample return is what came out of that. And so we've been working on that a long time. It's a very challenging thing to do. It's very expensive to do, but that's the next, I would say, next big goal for NASA's Mars program is the Mars sample return. And I showed a concept of that in my charts.
那请这位同学有在现场吗？辅仁大学英文系的郭永峰同学。郭永峰同学如果没有在现场的话，我们会直接跳到下个问题哦。OK， 这是来自大同大学资工系的林冠化同学。OK， 他的问题是 From what I understand, the main objectives of Mars exploration include political goals, resource exploration and development, the search for extraterrestrial life, future colonization plans, and general curiosity about the universe. Among these reasons, which one do you consider the most important?
Which one of these do I consider the most important? I would say what I think is the most important is the search for extraterrestrial life. We don't know, all we know is of life is life exists on Earth. And we don't know of life existing anywhere else, but it's logical with billions and billions of galaxies, with billions and billions of stars, with who knows how many planets, that there's got to be life someplace. And as far as I know, the closest thing we know of for possibly being extraterrestrial life is what's in Mars sample tube number 22 that I just showed that. So maybe that's what I think the goal is, to try to bring that Mars sample tube back and to find out, did life ever exist on Mars? Did life exist on Mars now? I think it would just be incredible if we could find out that life did exist somewhere else other than on Earth. I'm sure it is, but we haven't found it yet.
Right. 好，那我们请这位同学留在教室。哦，好，请拍麦克风。
Okay.
Do you have further question?
Yeah, no. You have answered my all question. Yeah, so thank you.
You're welcome.
Thank you. And then move on to the next. 下一个问题是来自台湾大学社会学系王自然同学。他的问题是 I'm curious about Mr. Lehman's perspective on the difference between space colonization and space society. I've seen these two terms used to describe the concept. So I wonder with which of these ideas of our current mindsets or approach toward Mars is more closely aligned.
These questions are unbelievably tough. They're really tough questions. Space colonization, colonizing space society. So I guess we first have to have a space colonization before we have a space society. And we're not there yet. It's many years in the future. Possibly the most near term would be sending tourists to the moon. I explained that before. Maybe we could set up, we have all these billionaires, they want to go become astronauts, go to space, and they can start colonizing it. Maybe we could have retirement homes for billionaires on the moon. Maybe that will happen. And then eventually, if we can lower the price down, we could have an actual space society, but we're still a long ways away from there. But I would say a space colonization has to happen before you have a space society. Dr. Chang, this is getting more in your realm, I think.
I think using the colonization is more aggressive. I prefer to use the immigration. Maybe immigration would be better, right? So colonization, like I have the military power or something to dominate the Soviet. So I would like to use the immigrations instead of the colonization. That's my personal point.
Okay, I see. That's a good point.
Thank you. 那这位同学也在现场吗 请开麦克风与镜头与讲者以及嘉宾互动。
有我在。
Hello.
这样我听到吗？ Hello.
Yes, we can hear you.
Thank you for answering my question. And yeah, I think it's really important to figure out what is our mindset to go to the Mars. So thank you so much for your answer.
You're welcome.
好，那我们来看下一个问题，是来自东吴大学英文系的同学，陈恩宇同学。I would like to ask Mr. Lehman's opinion about, is it really ethical to go and live on Mars? Like, even though we have the scientific ability, how do we conquer psychological challenges, the way of governance, and more practical things like that?
Is it ethical to go to Mars? Is it ethical to go to Mars? I guess if you're a Martian and you don't want all these immigrants coming to come to Mars, I can see that. But on the other hand, we're just born naturally to try to explore. And I think if we go to Mars, we should do everything we can to make sure we protect Mars and not contaminate it with our, say, coronavirus or flu viruses or something like that. So I can see how you think it's not ethical, but I just think it's part of our structure to want to try to explore. But if you do go to Mars, it's going to be, there will be a lot of psychological.
Sorry, please close your mic.
I can see there'd be a lot of psychological challenges for the people going to Mars from the Earth, because it's at least a 2-year mission. A round trip mission would be at least 2 years. And it would be very tough on the people doing that. Living in close quarters for such a long time. It is going to be a big challenge, yes, big challenge. So these questions are too hard. These questions are too hard. But thank you for this. I never thought about these things, but this is a good question, and I don't have the answers.
Yeah, I think this is the same question as what the astronauts they stayed in the space station. When they come back, they has a lot of mentally and also the physical issue as well. I think a lot of study have been involved to. I think this is a very first step. We explore the Mars or immigrate to the Mars. But sooner or later, we are going to face this kind of issue. But I don't think I can say that in my life age. Okay, thank you.
I agree.
好，那我们请这位同学开麦克风与镜头。应该有在现场。Hello， 请开麦克风。OK， 又关掉了，可以了。
Thank you, Captain Lehman.
Oh, you're welcome.
Thank you. 那我们进到下一个问题，是来自国贸系东吴大学国贸系的同学，他的问题是 ：If microbial life is discovered on Mars, should humanity prioritize scientific research and ecological protection, or continue with colonization efforts to support human expansion?
Wow, this is another tough question. If microbial life is discovered on Mars, I think that it will incentivize us to try to do more, to try to find more, and maybe we will want to to colonize Mars even more so. Right now, we're just colonizing with robots. We're just colonizing with robots. And I think if we do find microbial life, then that'll probably spur the efforts to actually sending humans there. So I think the answer is it will spur the efforts for sending humans there if we do actually find microbial life on Mars.
OK， 那这位同学有需要有追问的问题吗？
No, thank you for your answers.
You're welcome. Thank you.
Thank you. And let's move on to the next question. 是来自中原大学财经系的同学彭怡芳，他的问题是，What groundbreaking discoveries might the Mars rock sample return mission bring? Could it potentially reveal signs of life or the evolutionary history of Mars?
Well, I'm not a scientist, but I would say that, again, this Mars sample tube number 22, it might show that we have microbial life, and maybe there's other samples that have yet to been found that will reveal all this. And so all of this is all part of trying to understand how Mars evolved over time. And maybe some of this microbial life is still existing. Maybe it's not all dead. Maybe it's still flourishing. We don't know that. So I don't know the answer to this question because I'm not a scientist, but stay tuned when we get these Mars sample tubes right back to Earth.
Right. 那这位同学有在现场吗？如果有在现场或是有在线上的话，都请开镜头或麦克风与我们做互动。好，那再跟同学们宣传一次，我们可以透过工作人员背板的 QR code 问问题，或者是透过聊天室中的问题表单填写问题。那我们看下一个问题。哦，哇，那大同大学电机系的小可维，他的问题是 ：Will Mars become more habitable once the sun expands?
The sun expanding will be billions of years in the future, I think. So I'm not going to worry about that. That's beyond my lifetime. When the sun expands, I think everything in our solar system is doomed. When it stops producing energy, we're doomed. So it'll become less habitable, but that's billions of years in the future.
OK， 那我们请这位同学。
Thank you, Captain Lehman.
You're welcome.
Thank you. And let's see the next question. 是来自中原大学心理系的同学，他的问题是 ：What are the biggest challenges that Mars extreme environments such as dust storms, low atmospheric pressure, and intense radiation pose to exploration equipment? I wonder when rovers face prolonged dust storms, how can we ensure they do not lose power?
All right, the two rovers I showed today near the end, these were the Curiosity rovers and the Perseverance rovers. They all have a nuclear power source, so they're not dependent upon the sun for that. They use plutonium-238, which produces heat when that's used to produce energy, but it's still a very low amount of energy it produces, or power. They're only about, each of these power sources are only about 100 watts. And so that really constrains the operations of the two rovers. They have to go to sleep mainly at night to recharge their batteries. So they recharge their batteries at night using their nuclear power source, and that's how they're able to rove around during the daytime. So they're less dependent on they're not dependent upon the sun for the power source, but they still are very small sources of power. And let's see, other challenges. So for dust storms, for the other rovers I showed on Mars, they were solar powered, and they're very much impacted by dust storms, and because the dust will eventually accumulate on the solar rays, and you'll lose power over time. And the low atmospheric pressure, that's a problem for flying helicopters, and so that's why we did an experiment on that. And intense radiation, the radiation is more intense than on Earth, but it is, at least for electronics, we've figured out ways around that to survive the radiation environment. So there's a summary of the answer for this particular question. Thank you.
Thank you. And let's welcome 中原大学心理系01喂 sorry for announcing this. 同学有在现场吗？如果没有在现场的话，我们就会跳到下一个问题哦。好，那我们来看下一个问题，是来自东吴大学历史系的同学。他的问题是 ：Does SpaceX work wait?
Oops, what happened? Okay.
Which one should I? 听。好，那这个是来自台北教育大学的同学。What are the differences in Mars exploration strategies between NASA and other countries, such as China and Europe?
For Mars exploration, I think that NASA and the European Space Agency, we work very closely together. And so that is evident by the orbiters. The European Space Agency has 2 orbiters around Mars, and they work collaboratively with the NASA orbiters, working together to relay data back, and also with the science teams. And so, and then we have a working relationship, or working plan with the European Space Agency for the Mars sample return. In terms of China, I think that China and the U.S. do not work together very much in the Mars program. But I do know that I was at a conference at Caltech in the summertime this past July, and that there were some people from China going with poster boards. And I think China is very much wants to do a sample return mission, just like the U.S. does. And I wouldn't be surprised if China does it even before the United States, because I think they're very aggressive in their Mars program, and they might even beat NASA in terms of returning samples from Mars.
Okay, so let's welcome 黄嘉怡同学。黄嘉同学有在现场吗？黄嘉怡同学。好，那我们来看下一个问题，是来自辅仁大学英文系的同学。In terms of propulsion technologies for Mars missions, which technologies such as nuclear thermal propulsion or ion propulsion do you believe holds the most promise for enhancing vehicles' efficiency?
I think that let me just talk about it a little bit. In the video I showed, the last video about the Mars Sample Return Program, the Earth Return Orbiter, that mission is largely being designed by a European Space Agency, and they are using the propulsion system for that is ion propulsion. Ion propulsion is becoming very common now. So that's an enhancing mission for the Mars Sample Return from the European Space Agency. Nuclear thermal propulsion, that's also very viable, and but right now we're not doing a lot of research in that. I think we should, but we're not doing a lot of research on nuclear thermal propulsion, and I think we should. But we just haven't done it yet, or we just haven't done it enough yet.
All right. 那这位同学如果有在现场的话，也请开镜头或麦克风。如果没有的话，我们就会直接跳到下一个问题，应该会是我们的最后一个问题。好，来自 University of Leeds 李胜凯同学，他的问题是 How does NASA integrate automation and remote operation technologies in Mars missions to cope with extreme environments while ensuring safety? Could you share any practical experiences regarding their application?
These questions are unbelievably good and tough. I would say that in terms of remote operations, I just want to talk about how NASA, the European Space Agency, operate all the vehicles at Mars right now in unison. So there are 5 orbiters between NASA, the European Space Agency, at Mars right now, and 2 rovers at Mars. And so these 5 missions are all coordinated together in terms of how they work. So for example, the 2 rovers, they have data to be sent back, and then a decision has to be made of which of the orbiters return the data from these 2 rovers. And so there's a team of people from all the different agencies, NASA, European Space Agency, JPL, working to automate this remote operations. And so there's a team at JPL that there's a project manager for a network of the Mars relay network. And so that's centralized at JPL to control the 5 machines, the 5 orbiters and the 2 landers, the 7 machines. So they're all coordinated together by this the program we have right now. But it's happening right now. All these 7 machines between ESA, European Space Agency, and NASA all coordinated together in terms of their operations. And then, as a matter of fact, India and China and the United Arab Emirates, they also have orbiters at Mars, and those are integrated into the system to make sure we don't have a collision between all the different orbiters. That's a possibility. So China, India, and the United Arab Emirates, they do support this program in terms of what are the different orbits of their orbiters to make sure that we don't crash into each other. So that's ongoing right now.
好，那我们最后请这位同学开麦或镜头，有在现场的话。我没有在现场的话，我们将会先结束这部分的 Q&A 环节，那会进行到接下来的。如果大家有任何疑问的话，也请大家留下来，在会后留下来发问。我们因为时间的问题，我们会结束 Q&A 活动。那这边就是我们的最后一个活动。Okay. So this is the end of our Q&A section, and I'd like to I have to say I'm very grateful for the opportunity to learn about Mars and like the history of human exploration of this red planet. And just like I believe that Mr. Lehman has mentioned, Mr. Brown's visionary outlook on Mars exploration. And just like that, we are always inspired by this by the passion like that Mr. Lehman and also Dr. Zhang has shared with us today. So thank you so much for bringing us such a insightful and engaging talk. And I believe all of us will continue to follow and support the future research in this field. So I have to welcome Mr. Lehman, and Mr. Lehman has a short takeaway message for all of our students here. And let's welcome Mr. Lehman again.
Okay, thank you, Iris. So I have one more chart, and remember I told you about the project manager Mimi Yang of the Mars helicopter, and I attended a briefing about a year ago, and I'm going to show you what this is, to me, the secret of success in life that Mimi Yang put together. Let me see if I can share this chart. Here we go. So I'll share this, go full screen. So this is not my invention. This is from Mimi Yang, and it's the secret of a success in life. Let's see if I can go down here. Yes, it's called Reaching for the Stars by former Mars helicopter project manager Mimi Yang. And this to me is the secret of having a successful life. And what you need to do is figure out what you're good at, and then figure out what you like to do, and then what is needed. And you need to find a combination of those three things: what you're good at, what you like to do, what is needed. Say, for example, that you're good at math, and you're good at building things and operating things. You understand physics, and so maybe you want to become an electrical engineer or a chemical engineer. Maybe you want to work on one of these space missions. Maybe that's your goal, because it definitely is needed. Definitely needed. And then what you need to do, you need to add to that lots of hard work, lots of critical thinking, and that's how your dream can become a reality. So this to me is the secret of success in life. The most important one on here is hard work. Hard work. And so this to me is really a food for thought for Reaching for the Stars, brought to you by Mimi Yang. So thank you very much, everybody.
Thank you so much for the wonderful speech. And let us give Mr. Lehman our biggest round of applause to express our sincere appreciation for his insightful speech and invaluable contribution today. All right, so let's move on to our last session. I'll switch Mandarin again. And 又到了要公布我们的得奖名单的时间，我们有请刘登凯博士为我们公布今天的得奖名单。
Okay, David, I'm going to announce the people who earned the award here because they have a good question. First, I really appreciate you answering all the tough questions, really tough questions.
Yeah. They're too tough. You need to get students that aren't as smart, I think.
Well, I'm glad that you are the one to answer the questions, not me. And, okay, so I'm going to switch to Mandarin right now. 那我刚刚讲说，我们这个同学们真是很厉害，尤其是很多这个不是属于做科技的同学们问的问题，是平常我们都听不到的。所以我就跟大家分享一下。我先说明一下我们这个第一部分就是事前的问题，我选了3名出来。第一个是中原大学财经系这个彭怡芬同学，他是说这个人类登陆火星最大的科技挑战是什么？我想这个我们已经答了的，所以很不容易，同学们可以想到这个问题。然后第2名东海大学化学系陈怡轩应该是同学说，在多久可以移民火星？那我想这个 David 也答到这个问题。然后第3名是这个静宜大学食品营养系的这个柯宇恩同学，他是参与NASA 的太空活动这些， 我想我没有答复，你可以留下来。如果你还在线上留下来，我们大家可以谈这个问题。那这个演讲后的这个问题的话，这个都是太厉害了。我还好，我跟 David 说是还好，不是我在答。虽然我跟他一样的，我们做火星非常久的这个同事了，是吧？那第一名，我想给这个大同林冠华同学，探测的这个重要的目的是什么？他非常好，他选了好几个。我想这个寻找外面的生命是非常非常重要的一件事情。那第二名，我有第二名的话是中原大学心理系同学李一，那字我不太念，我念停，可能我也不一定了。那如何失去这个动力？我想你这个心理系同学能够想到这个，真是不容易的，所以要给你们这个系主任跟你们都要嘉奖一下的。这个是第二名。那么第三名的话，我选了2位，一位是东吴大学英文系的这陈恩宇同学，他是说到火星上有没有什么这个 ethic 的问题这个我从来没想到，我们就是要去嘛，对不对？还要想到 ethic 的问题，没有想到。然后我觉得这问题挺有意思的。那第二个第3名是中原财务系的彭一芬同学。这彭一芬我给了2个，这太厉害了。还是说火山岩石返本的任务可能性带来哪些这个突破性的发现？所以我们这个彭一芬同学拿了2次。好，我就宣布完了。如果你们再有什么问题的话，可以在信上问我们的。
谢谢邓凯博士。那接下来，我们4月份的讲座将会由加州阿罕布拉市长 Noya Wang 主讲。那他的主题是 Bridging Dream and Reality: My Transition from Civil Engineering to Public Office。所以无论你是工程专业的学生，或是对 GI 转型还有公共事务等充满兴趣，这讲座都将带给您启发以及收获。也欢迎您报名我们下个月的讲座。那我们再次感谢 Mr. Lehman， 还有我们的介绍嘉宾张贵祥博士，以及本次与会的学生同学们、学校还有来宾们。欢迎大家填写现在荧幕上的回馈表单，让我们可以做得更好。最后要在这边 ，Thank you。我们要在这边感谢活动中参与幕后筹备的师长同学。那如果在我念到您的名字的时候，欢迎同学或是师长可以挥挥手，让大家认识您。感谢大同大学的何明果校长、电算中心的包仓龙主任、课程林尚林老师、录影于佩轩、邵诗源，以及与我们合作的台北教育大学谢怡君教授、中原大学张新德老师、叶礼豪主任，感谢东海大学蔡嘉信老师、王崇明教务长、福音科技大学陈义谦老师、东吴大学秦玉国老师、静宜大学建慈老师、陈明柔主任、明川大学网络电视转播陈春满小姐、台北市立大学陈姿玲老师、慈济大学谢梦玲老师、江允志老师、辅仁大学周德莲老师、台北科技大学秦先玉老师、潘恩勇小姐、嘉义大学王明宇老师、沈永琪主任、尤建新同学。感谢这次的工作人员，负责联络事宜的林小丽、宣传吴香宁、林婉莹、潘怡轩，以及确认设备状况的林子静。接着最后要感谢大家今天的参与，大胆提问才能成就非凡未来。我们4月讲座见，谢谢，拜拜。
Thank you, Dave.
Thank you.